Guys, excuse me. Is there a doctor in the house?
Over there.
Over there. So you're the doctor.
That's right.
What's your name?
Paul Megwitz.
So give me the dirt on your story.
All right. The concept of ecology is to basically take waste materials.
First of all, you're a doctor of...
I'm a doctor of plant biology, developmental plant biology.
You're the right guy to talk to here at the Toronto, at the Urban Agricultural Summit here. And we're in the trade show part, so go ahead.
Well, the story of ecology is the story of how you take things that nature throws away and bring them back to productive capacity. So right here would be the waste stream of Hamilton, Greater Toronto, and whether you're eating fish in fish boxes or high-end furniture or electronics, you basically put it in this very high compressive strength, ultra lightweight medium called styrofoam.
Yeah, when I put my hand in it, there's a cool sensation.
Yes, and that's because of we'll say Dr. Bob over here, his recognition that if we left it just shredded, it would be sticking to us because of the hydrostatic forces in styrofoam. So styrofoam is one of two things. Either you eat off of it and it's dissolving and killing you at a known rate, or it will last forever because it's non-biodegradable. And it turns out to be the latter. Basically, it doesn't degrade, maybe up to 30% of landfills. And bacteria, microbes, fungi don't break it down. So what we did was recognize a simple thing. Soil is sand, silt, and clay, plus organics. Sand and silt is silicon dioxide. I know you don't want to hear chemistry, but that's heavy, 120 pounds a cubic foot. This is 10 pounds a cubic foot, dry, like it is, and mixed also with this material, which actually is something more like 50, 60 pounds a cubic foot. This is a composted food waste of Toronto, and you mix them together, and you get what's in here, which is Gaia soil. And I didn't start out loving styrofoam, but the fact is that soil holds more water per its weight than any other green roof medium. The other story about it is that it's also carbon neutral. You don't have to expand shale or add heat. You simply take the waste stream, add compost, plus a couple percent clay, and as Bob can show you, you can grow plants in it.
So how did you get into discovering this?
People asked me 30 years ago if you can grow edible plants on rooftops, and there's a simple answer to that, it's no. Because soil weighs 120 pounds a cubic foot, that's because of the sand. And if you could replace that, you could grow anything. So I've grown more than 70 species of tomatoes, eggplants, high-end lettuces, arugula, like this oregano, across the board. And never grew orchids, but I'm virtually sure I could get those too, as well as something like 400 species of native plants. So we got to this because I wanted to see a green building be really green, as to say something like plants growing on it. And for that, full-scale urban farming needs full-scale recycling, and we need to basically go from what we're throwing away to what supports us.
Okay, thanks for the dirt. Let's get more dirt on this. Now you, Bob, how are you related to this formulation?
Yeah. Well, I guess through telephone calls and the Gaia soil coming to Ontario, that we've learned they needed a company. Somehow they've located us. There's a company that does composting. We do composting. We do the recycling. We pretty much do it all. My background, I'm actually a farmer, so this fits into place for me. I do a lot of crops. You see, what's here is not just food that we grow as tomatoes. I do very well. We're going to have other crops. This is an oil crop. This is canola. This is an oil crop. On the other side, we have wheat, which goes for flour, for bread. And we'll see, can we grow the other types of crops? And we're sure we can. And this is where I specialize in. And the thing of styrofoam, when I first heard about it, also struck me the same. I'm an as-and planner. I have a license under OMAP. So I look at everything that's going to go on agricultural land to show benefit. Can we use it? Will we use it? This doing the green rooftops fits into the crops that we would grow out on the farm and now build it up on the rich buildings.
So let's compare this to conventional growing. Does this grow quicker? Is there a better nutritional yield, or what's the dirt on that?
What we found was quite interesting. I got 4 days. 4 days the canola was up. Just after the 4 days, part of the second, in the next 6 hours, the wheat was coming through.
Wow.
This right here, what we see is only 13 days old.
This is only 13 days.
This is 13 days.
And what would you see in a normal situation? You wouldn't see as much
In the
or
13
anything.
days, it would just be nicely sprouted. We'd see the sprouts up. We'd see the wheat, or we'd see the canola just popping through.
Wow.
We would see that.
Kind of like my hair.
It's well,
Nothing like this.
we're not going to pick on you. It's not pick on.
Well, here it's kind of like his hair. I know it's like your hair. Okay, but anyway.
The story is that basically roots need oxygen, and what happens with this kind of open architecture is that oxygen can get in there. So what inhibits roots, all root growth open, is a lack of oxygen. If it has water, the water can actually keep oxygen from getting in. Here it has water and air, so basically you get this growth. It seems to be significantly faster than what you get in the standard mode.
For growing the crops, I think Paul's pretty much said it all, but I will back it up. Using the compost, we do a lot of composting. One of our contracts we have is with the City of Toronto. We do the SSO program. The compost that you're looking at here is from the SSO program here. It's a finished compost that we finished, taking it down, finished from Power Grow.